Okay, so here we go, guys. So let's talk about transformations. So, and I will definitely do this right because I know I messed up for this week. So these are all parent functions. Parent function, most basic functions for all these different types of relationships, like quadratic, absolute value, square root, cubic, exponential, logarithmic. You know, you guys can't forget logarithmic, right? I know we haven't talked about logarithmic yet. Now we're talking about it. So let's consider y equals x squared. So when you do x minus 4, you guys should know what that does. What does that x minus 4 do? Goes 4 right, exactly. So let's three key points on y equals x squared. I'll do 0, 0. I'll do 2, 2. Sorry, 2, 4. Yikes. And negative 2, 4. So what happens here? How are you going to alter the table? How's the table get altered, guys? Yep, just do this. Y stays the same though, right? That's all. So what happened to the x values? We added 4. That's all. So in this case, for part C, you're doing a plus 4, comma b. Does that make sense? We're good with that? Okay. Now for part D, what do we do? What do you guys think for part D? Actually, let me it's gonna yeah, you can say it a couple ways. It's gonna horizontally stretch. By a factor of 2. The horizontal stretch by a factor of 2. So if I make 3 key points again, y equals x squared, 0, 0, 2, 4, negative 2, 4. So for this, if I make a new table, I'm going to multiply the y values by 2 to counteract it. Correct. Yeah, that looks good. So x values get multiplied by 2. Right? Because if I plug 4 in, I should get 4. Or negative 4, I should get 4. So in this case, what happens to A? It's 2a comma b. Does that make sense? 2a comma b? Okay, cool. Outstanding. Okay, that was easy. Okay, let's consider absolute of x. And again, we go to decimal, so you guys know the graphs look. So what does the plus 3 do on the outside? Up 3. Love it. Up 3. So again, if I make a table, 0, 0, 2, 2, negative 2, 2. So for the transformation, I'm going to add 3 to the x, right? So add 3 to y. So 0, 3, 2, 5, negative 2, 5. So this case would be a comma b plus 3. Okay, makes sense? All should we review, right? Okay. Okay, root x. Root x we know looks like this roughly, right? That's how a square root function. I know we're not graphing these, but we're just kind of doing it. Example 2, okay. I can move forward. I'm not going too fast. Okay, I don't want to bore you guys but go too fast either. All right. Next up, root x. What does the 3 do on the outside? You go say? Yeah, vertical stretch by factor of 3. Okay, cool. So the key points here. My domain is clearly x is greater than or equal to 0, so gotta be mindful about that. So if I do this, easy peasy, this right here, multiply by 3. So what do I do? Multiply y by 3. So in that case, I have a comma 3b. And that should be, that's a typo. Yeah, should be that. That's a typo. Okay, all's good. Yeah, okay. Just kind of we're compartmentalizing these like, hey, what if we, multiply y by something, or multiply x by something, or add something to x, or add something to y. We're going to eventually put all this together in a little bit. Okay, example 4. So, these should be pretty easy. This is the point we're considering. We're changing, we're transforming. Transforms a change. All right. So what am I changing for part A? 3 comma what? Sorry, -3 comma what? Perfect. Part B. Yeah, because you take away 6, right? Part C. And part D. Wow, you guys are awesome. Good. All right. I'll tell Mr. Ban, he'll be very happy you guys got that. Okay, good. All right. Now let's put it all together. Okay, I'll promise I won't mess this up this time. Okay, so here's what we have to do. My parent function, this is a transformation of y equals x squared. That's my parent function. So I'll do 0, 0, 2, 4, -2, 4. Now over here. So let's talk about the change we're making. We're adding 3 to y, right? I guess I like to call it cloud method. This is the part that's a little tricky. 2x minus 1 equals 0. Or set it equal to a. What's going to happen? You have that. And you have that. So I need to add 1 to x, then divide by 2. Or multiply by 1/2, same thing. Because you're doing the opposite. You're undoing what's on the inside, right? You're undoing it. So even though, yes, I did say PEMDAS, so I am going against what I said, so I apologize. Yeah, what does x see first? It sees this and this, but we actually have to do the opposite. So if you undo it, you go the reverse, right? You add 1 to x and then divide by 2. You do the reverse. Everything gets reversed. Add 1, divide by 2. So the y is easy. That's just 3, 7, 7, right? The x changes. You add 1 and divide by 2. Add 1, divide by 2. Add 1, divide by 2. And you can always check. Like if I plug in 1/2, I do get 3. If I plug in 3/2, I do get 2 squared, 4 plus 3, 7. If I plug in -1/2, it's -1 minus -2 squared, 4 plus 3, 7. So I feel good about that. So to undo it, set the inside equal to a, or any arbitrary letter. See what operations are happening. I'm adding 1 to a and dividing by 2. So 1/2 comma 3. 3/2 comma 7. And then 1/2 comma 7 to guarantee the symmetry. So it's still a parabola, but it's a very skinny parabola, or kind of skinny. We're good? Yep. Okay. That's the approach we take. Okay, so now I feel better. I've done this cleaner. Okay, we're good? All right. Go and try example 6 on your own. Or you could check with someone in your table group. I'm going to do, I'll freeze the screen and we'll compare. All right. And do the parent function first, guys. y equals root x. That's a good habit. Okay, hopefully you guys get that. So it's hard to tell, but there's actually a horizontal compression by a factor of 2. And it's hard to tell. But this flip, that's easy, that's obvious, and there's a shift of 4 up. So the x values must be divided by 2. And the y values, you multiply by -1 first and add 4. That does actually follow PEMDAS for the change to y. Because you multiply before you add. It's the x that's a bit counterintuitive or reversed when you change the x, but y is intuitive.
What do you do with the negative sign, like in that process?
That gets multiplied to -1 for y. Because it's on the outside. Because it's on the outside of the function.
Okay.
Because if your parent function is root x,
Right.
put a negative, it's like all your y values change sign, which is a inverted flip. Or a reflection about the x-axis.
But all the way I can still on. Oh, you do it before you add before.
I multiplied by -1 and added 4 though.
Got it, you did it before.
Yeah. So I did it beforehand. I know you can't tell. But okay, we're okay? Okay. Can we move forward? We're good? All right. Okay, we're almost done with the notes. This is exciting. Let's get the first unit done. Okay, y equals 2 to the x. I would do 0, 1, 1, 2. I'll do -1, 1/2. Same for this guy. What are we doing here? Only y changes. Keep x as is. Here we're gonna multiply y. Then subtract 3. Wait, did I do that right? I added 3. Sorry, my apologies. That would be -3.5. Is that right? Yeah. -1, -4. Oh, yikes. -1/4. -3.25. Is that right? Yeah, okay.
Because you multiply it by -1/2 and then -3.
You guys remember asymptotes? Yeah. There's a horizontal asymptote y equals -3. Because the parent function has horizontal y equals 0, right? And then it gets the 3 down. but also we flipped and we also vertically compressed. The vertical compression is hard to tell because exponential by nature it's having a fast change. But yeah, that's what we do again. I'm being incredibly consistent here, right? Very consistent. We're good? Okay. Last one. You're given a funky graph down below and you have to make changes to it. I'll wait till people are caught up. And good, we're doing great on time today. This is awesome. Okay, here's what I'm going to do for this one. I'm going to make a table for the given points. -4, 0, -2, 2, 0, 0, 4, 4. Now, what's happening? Add 2 to x. Okay. And what's happened to y? Then, right, put in caps, then subtract by 1. Cool. So add 2 to x, -2, 0, 2, 6. Multiply 3, subtract 1. Multiply 3, subtract 1. Multiply 3, subtract 1. Multiply 3, subtract 1. So I'm being very thorough here to the best of my ability. See how a circle gets stretched, right? Kind of makes sense, right? It's kind of weird, but they get stretched. And 611. And there's a shift of 2 right and 1 down. That makes sense also. Okay, well, I could do better. Hold on. So happens when you freehand it. Okay, that makes sense. All right. So the good news is that you guys have time for the quiz and homework. But before we do that, let's talk about the tests. So this packet is very thick. Yeah, so this is if you want to get started on your in terms of the test, I haven't written it yet, but you know that's going to be stuff. I mean, I'll give you guys more details. But you know, some of this stuff, you know, it's going to be tried. I did. I know. I feel a lot of trees as a result. Actually, it took more than a whole ream because I have 40 students. It actually took 578 sheets of. Yeah. So, well, actually, it's 28 pages times 40, but then divided by 2. So yeah, 5. Yeah, I used the whole ream. Yeah, I used the whole ream. More than whole ream. One of those thick packs. Yeah. The answers are included as well. Yeah. So as I told you guys, all the answers are included as well. So what I did, just so you know, there's some method to my madness. Yes, I'm mad. But all this stuff I'm giving you, manic is probably a better way of putting it. But there's a little bit of method to the madness because what's happening is I gave you kind of an overall review first. Like there's some piecewise functions. There's is this a relational function or not? Even odd behavior, cloud method transformations, composite functions, domain, one-to-one functions, inverse functions, right? I have the answers. Now, based upon how you do, let's say you go through this like, oh, geez, I really screwed up the composite functions. Or like, oh, man, like I just can't figure out inverses, right? Whatever. Guess what? Later in this packet, I have very specific drill packets on those skills. Like if you need more help with inverse, boom, there you go. You got more than enough inverses that your heart can desire, right? So you got all this stuff here. You have the answers. Or like, oh man, I really need more help with like extrema. Great. Some work with extrema. So I think we have some stuff in extrema. I hope there's some stuff in extrema. Ooh, there are not any extrema. That's not good. Okay, well, you know what? There's stuff in extrema. So that's good. Okay. I just realized that. That's interesting. Okay, so you have stuff in extrema and increase decrease. That's just you need to do that. Domain, a lot of stuff on domain here. And through a log one as well. And then stuff from the textbook. And the answers are right here. It's my handwriting, obviously. Stuff from the textbook, like your graphing, transformations, blah, blah, blah. Or just say, sorry, domain range, that's what I meant to say. Extrema, even odd behavior, transformations, moving around piecewise functions, composites. Yeah, inverses. I hope there's more stuff on extrema. I guess that worksheet will do. Oh, there's some folks. Yeah, so yeah, it's pretty thorough. And the answer should be shown on the margins as well. So yeah, you got more than enough practice. More than enough. Granted, there might be a question or two I might put that might just be a little bit more higher order critical thinking. I'm not going to say what exactly. I'll give more details. I'll write the test for the weekend. By Tuesday, I'll give more details about the test. I anticipate, I'll stop the recording now.